Hey, good morning. Stephen Fleet here again. Hey, a couple of days ago, I posted a video about a way to test for prime numbers, basically as a series of signs. Recently, I started working on it again. Uh, Discovered something I think is probably a little bit quicker and actually helps clean it up and condense it. So essentially, you take this is one of the value or one of the equations that I posted earlier about y equals x plus z, where z is defined as this. And what it does is it generates all your primes from 5 and above and also your semi-primes from 5 and above. Now, the question is, how do you get the semi-primes out? For example, x is 8, y is equal to 25, which is a semi-prime. One of the ways you can test and one of the ways you can edit the equation is with the indicator function, which then allows you to generate only primes. So your equation only generates primes, and if there's a semi-prime, it's a 0. So essentially you take, well, let's start with this equation called r of y of x. So you take your y of x and you put it into the Euler number to the power of 2 pi I times y of x divided by t, and t goes from 2 to the floor of the square root of y of x. That's as high as you need to go, and then subtract 1. Now what's interesting here is that if you can do the math behind it, but if your number is composite, your y value, your r of y of x will always equal 0. That's because this number here, if it's composite, say it's 25, and 2 divided by 25, 3 divided by 25, 4 divided by 25, eventually you're going to get to where one of them is 5 divided by 25, and the cycles of 2 pi, that'll equal 1. And then for the I sign, that'll equal 0. And so 1 plus 0 is 1 minus the 1 will equal 0. And since this is an Euler product, that'll cause the entire series of it to equal 0. And if it's not prime, it won't equal 0. And that's where your p, we'll call this the prime function, is your y of x function, which is this here, times your r function, which is either not prime, or which is either 0 or not 0, divided by itself. And you could probably square these instead of absolute values. So basically what happens is it'll be times 1 if it's prime, which will actually give you the prime values, or it'll be times 0 if it's not prime, and so basically it'll wipe itself out. So your function will only end up generating primes. This is not only a cool test, but also a prime generating function. Thank you.